Alright guys, so some people were asking, so I posted the divider if you want to try to stay organized in your notebook. So on the first one I put intros to conics, so that's this one here. And then we talked about parabolas, circles last week, and I'm going to review them a little bit today. And then we were looking at ellipses and hyperbolas on Monday. So hopefully you got some good ideas there about how they're different and what's cool about them. So very briefly, as you maybe went through that Desmos activity or whatever, you noticed that with ellipses they had a center. Sometimes it was 0, 0, sometimes it was h comma k. I feel like we got smushy ones or we got stretchy ones, and they're just like smushy or stretchy circles. They have something like a major axis, talking about a major axis and a minor axis. And so it seemed like with the major axis it was always saying it was parallel to either the x-axis, like this one, or the y-axis. It's the longer one or the larger one. Hopefully that makes sense. And an additional thing that I don't think was mentioned there, but we'll talk about in a minute, is that this is where our vertices lie. So like at the ends of those we get our vertices. We have our minor axis, which hopefully makes sense to be the shorter. And along that shorter one, kind of in the center, we get what's called covertices. Now another thing that we also have to talk about, if you remember back to my very first video when I did the paper folding, we also had that additional F point that I kept putting on there. The F point is our focus, which parabola had a focus. An ellipse rather has 2 focus points. And so Miss Lino and I like to argue a lot about the pronunciation here, but I feel like however you pronounce it, as long as we know what we're talking about, the plural, I think, and the way I always learned it, of focus is foci, or foci is how some other people say it. So I think I've always said it as foci, and Miss Lino always says it as foci. Whatever you prefer. And we have 2 of those along our major axis, so we'll get to that. Now with a hyperbola, which was also one that we looked at, all the centers were 0, 0, and that's just because hyperbolas are a little bit tricky. They can be at h comma k, but they get a lot harder once they get shifted. And that's because of the fact that a hyperbola has asymptotes that we have to deal with. So our hyperbolas can either be on the x-axis or on the y-axis. So this one's on the x-axis, and that's because your vertices are physically touching the x-axis. Nothing's touching the y-axis. Or your vertices are on the y-axis if your parabolas are kind of pointing up and down like this. So that's how we can tell. We had asymptotes, and they always seemed to be this linear equation. They were always the same, except for one was a plus, one was a minus. So it's interesting to figure out where that slope comes from, which again we'll get to. And also when we did the paper folding with this one, we had 2 focus points, or foci. So, and they kind of appear inside your branches, kind of like inside the parabola that we had up here. So that's kind of the quick overview, maybe some things you thought of while you were working. So the next page, we don't have anything here. We might get to that next week. We had our parabola practice, which I'm actually going to come back to that in a minute, our circle practice. And now we have ellipses. So on 110 we have ellipses. And our 2 ellipse equations, we have the more basic one, x squared over a squared plus y squared over b squared equals 1. And then if we want to get a little bit fancier and not be centered at 0, 0, we have x minus h squared over a squared plus y minus k squared over b squared equals 1. So sort of the important thing to notice about an ellipse, or a couple of important things to notice about the equation. Both variables are squared. They are always equal to 1. They always have different denominators, and they're always being added. So that's some important stuff. Now, your vertices will always be along that major axis. So it will either be whatever is under x square rooted, so plus or minus a comma 0, or it'll be 0 comma plus or minus b, this one here. And the way we determine which one is our vertices is the vertices are on the major axis. So the big thing about ellipses is that really what matters is whatever is larger. So if I square root this one and it's larger than the square root of that one, a, or my x values, because we're under x, will be my vertices. If b is larger, so if underneath x we have 4, and if underneath y we have 25, so this one's larger, the square root of that, 5, will be my vertices instead, so 0 comma plus or minus 5. If under y is larger, so whatever is larger. And then your co-vertices are the other ones, so whatever is left. So you do need them both. Just whichever the larger ones are your vertices, the smaller ones are your co-vertices. And then we have those foci points, and your foci is along the major axis. So again, whichever one is larger, you're either going to have plus or minus c comma 0. C is that focal length, or you're going to have 0 comma plus or minus c. Again, it's going to go with whichever one the vertice was. So like if I picked A here, I'm going to pick C in the X position, or if I picked B here, then I'm going to pick C in the Y position there. And we'll talk about how we find C after I go through these ones here. So if my center is not 0, 0, and it's H comma K, things get a little bit trickier because over here I'm just adding and subtracting things to 0, so they just become that number. But if I don't have a center of 0, 0 anymore, I have to add that A value to H, so it'll be H plus or minus A, comma K, or it'll be H stays the same and K changes by plus or minus B. Because we're not just adding it to 0 anymore, you have to add it to whatever your center is, because you start at your center and you count out however far you have to go, whichever is larger. Okay? Your co-vertices are just the other ones, so these are the smaller of the two. So whichever one is smaller is going to become your co-vertices, so you really need them both. And then again, your foci, or foci, see, even I change it up half the time, will be H plus or minus C if A was larger, or it'll be K plus or minus C if B was larger. Okay, so again, whichever one is larger. So, super important, and I didn't leave enough space, is how we find our focal length. Our focal length is at C, and so the way that you find C, or rather C squared, you actually do B squared minus B squared. It'd be so nice if it was Pythagorean theorem, but kind of the way I remember it, and you'll see this hyperbolas as well, like this is a plus here, there's a minus here. It's reversed for hyperbolas. So we'll try a couple. So if we had x squared over 9 plus y squared over 25 equals 1. There's a couple things we want to find. We want to find our center, vertex, co-vertex, foci, whatever you want to say. So my center, I look at the numerators, nothing up there being added or subtracted, so we're at 0, 0. My vertices matter whatever is larger. So y has the larger number, so because we're 0, the x will stay the same. My vertices are going to be at 5 and negative 5. My co-vertices, or whatever is smaller, so since x was smaller, we're going to be 3, 0, and negative 3, 0. Okay? Now, I did all those based on the equation. I think sometimes it's easier to just graph. So I can tell that my center is 0, 0. The x direction I need to go is 3. The y direction I need to go is 5. And then you can kind of just see, okay, these are the bigger ones, so these are my vertices. These are the smaller ones, so these are my co-vertices. So if you need to graph it first and then just like write down the points after, that's fine. And it's also fine that it looks like a potato because it's supposed to look like a potato, unlike a circle. Then we get to our foci, and to find the focal length, that's c squared, we have to take our a squared and our b squared, which is not 3 and 5. These are a and b squareds, and it doesn't really matter which is which. Like, they're just letters representing those numbers. We just always want to subtract so that we get a positive number. So we're going to have 25 minus 9, which is 16. And then we got a square rooter so that we just get c, so that's 4. And so then I need to add or subtract that 4 to whatever was larger, which my vertices had the y value that was larger. So all the way back to my center goes, it's going to be at 0, 4 and 0, negative 4. Now again, that focal length is from the center, or from your vertex, out that much. So my center was at 0. I need to travel along that longer axis 4 units. So I get to the focus point by doing that, if I can just count it on my graph anyways. And then I can just write the focal points down. Okay? One that's slightly harder because it has a different center. So I got x minus 2 squared over 4 plus y plus 1 squared over 25 equals 1. Okay, so we got a center at 2, negative 1. That's 2 and negative 1, always opposite. My vertices are going to adjust the y value of my center because y is larger because the 25 is under. So I'm going to add and subtract 5 to the y value of my center. So 2 will stay the same. When I add 5, I become 4. And when I subtract it, I'm at negative 6. Now again, sometimes it's easier for me to just graph it. So like my center is at 2, negative 1. Now I can tell the directions that I need to move and like how far to move. So in the y direction, because it's larger, I need to move 5. So 1, 2, 3, 4, 5. And then I can just see I'm at the point 2, 4. Ta-da! And then I also have to go down 1, 2, 3, 4, 5. Oops, off the graph. And I can see that I'm at 2, negative 6. Kind of. Now your co-vertices just go in the other direction. So my co-vertices are the smaller ones. They're in the x direction, adjusted by 2, because we're always square rooting. And so we'll be at 4, negative 1 when I add 2, and 0, negative 1 when I subtract 2. But again, like I go to my center, I need in the x direction to travel 2, so 2 and I get a co-vertex, and 2 and I get a co-vertex, and you get a real life potato. Okay, so then our focus, we are going to find that focal length by doing that c squared, and again, always subtracting to get a positive number, because we don't want to square root things that are not positive. So 25 minus 4 is going to be 21 square rooted, which is not the prettiest of numbers, but that's okay, we can approximate it. So for my focus points, we are going to adjust the y value because that was larger, so we're going to do negative 1 plus or minus that root 21, which root 21 is like almost 5, but like a little bit less than 5, but not less than 4. So like from that center, I can go out like 4 and a little more. So 1, 2, 3, 4 and a little extra. And I end up just away from that vertex like I'm supposed to. It's so super cute. Look at those foci. Love it. Okay, let's talk about hyperbolas. Sorry, I could talk about these all day. Hyperbolas. So, let's just talk about the easy ones. So without a center that's been adjusted. So if we have x squared over a squared minus y squared over b squared equals 1. Or one type hyperbola. Now again, it can be adjusted and probably won't get to those. The other way we write a hyperbola is just in a different order. So y squared is first. Minus x squared over y squared equals 1. So a couple important things about hyperbolas. Both variables are squared. They are always equal to 1. Denominators are probably different. They don't have to be, but they're always subtracted in between. The subtraction is the big deal there. It's making it a hyperbola and not an ellipse. Okay, so for both these guys, we are centered at 0, 0, because nothing is happening in the numerator, nothing's being added or subtracted. Now again, we could do that. Maybe I'll have you guys let me know how you feel, and if we want to do that, we can do that. The big thing with hyperbolas, so hyperbolas can either have vertices on the x-axis or vertices on the y-axis. And the big deal with hyperbolas is whatever comes first. So with ellipses, it's whatever's larger. With hyperbolas, it's whatever's first. So here, since x is first, I know that my vertices will be on the x-axis at plus or minus a, comma 0. Over here though, because y is first, we'll be at 0, comma plus or minus b. Now if we had the h and k thing, it'd be similar. We'd have to add it to h and k rather than 0, so that's why the 0 makes it a little bit easier. Now your asymptotes were always a linear equation, where I hope it's okay that I put plus or minus, because they're always the same equation. It's just one is positive and one is negative. So they just have one positive slope, one negative slope. The way that you get those is you just do slope. And slope is rise over run, and rise is like y over run, which is x. So I just take like whatever's under y square rooted divided by whatever's under x square rooted, always. It's just that the y might be in a different spot, so you just have to be careful. So that's super fun and easy. And then we have foci as well here that are like sort of kept within your hyperbola branches, and you are going to add or subtract that focal length once you've found it to, again, whatever was first. So here, since x was first, I added to x. Here, since y is first, I'm going to add it to y. And again, because it's 0, it's easy. This would be h and k if it was an adjusted center. So to find that focal length, little baby formula again. It's actually a c squared, because like everything is squared. And this one is the Pythagorean theorem. So c squared equals a squared plus b squared. So in the equation, a hyperbola is subtraction, but focal length is addition. And then kind of same deal with ellipse. So in an ellipse it's addition, but for focal length it's subtraction. So it's kind of a way to remember like which goes with which, I think. So if we try to, we got x squared over 4 minus y squared over 9 equals 1. Okay, so center is 0, 0. My vertices, I know that my vertices will be on the x-axis because x is first. So my vertices will be at 2, 0 and negative 2, 0 because we're square rooting them. My asymptotes have a y equals mx equation where I just find slope, and slope is y over x, so 3 over 2. One is positive, one is negative. So if we graph this a little bit, we got vertices at negative 2 and 2. So like your hyperbola branches have to go through there, but like the asymptotes help. So if I start at 0 and I go up 3 over 2, we get like this asymptote. And if I go down 3 over 2, we get the negative asymptote. And that's just kind of helpful to show me maybe how big my hyperbolas should go. Then we have our foci. So to find that foci, we got to do that c squared equals a squared plus b squared. Now again, these are already a squared and b squared, and it really doesn't matter which is which, because I'm just going to add them. So 4 plus 9, 13, square rooter. That's a bummer, I don't know how to square root that, but I'm just going to add and subtract it, 2x, because x was first, and square root of 13 is like, a little more than 3. A little more than 3, not quite 4. So from that center of 0, 0, I'm going to go out 3, a little more, and you get a focus. Look at that, so cute. Inside of that hyperbola branch like it's supposed to be. Alrighty, this is a long video, I'm so sorry. We're going to do one more hyperbola, and then I'm going to have you guys try some examples of each one. Oh my god, what the heck? Let's do one. No, let's not. I'm scared. You tell me. I'm going to do one without a weird sign. I'm going to still do 0, 0. If you change your mind, if you want me to do a crazy one, let me know. Okay, so we got that one. Which may look funny that the other guy doesn't have a denominator, but we always have a denominator of 1, so like no need to worry. Center is still 0, 0. Vertex. So our vertices here with a hyperbola always matters what's first, and since y is first, my vertices will be 0 comma something, and they'll be 2 because again I square rooter. My asymptotes will be y equals plus or minus the slope times x, and so my slope is just rise over run, or y over x, or 2 over 1, 2. And then my foci I can find by doing c squared equals a squared plus b squared, and I do have both those numbers. Again, it's 4, and I can always be over 1. Ugh. So again, square root of 5, don't quite know her, but we're going to add and subtract her to the y values because y was first. So after all that information, we can go graph now. So we got our center at 0, 0. We have vertices at 0, 2, 0, negative 2. My asymptotes are so helpful here. I can do my slope of up 2 over 1. Get that little asymptote. You can go down 2 over 1. You get other asymptote. And since I'm on this, I have to like follow these asymptotes out, so you get more of a smushed up hyperbola branch. Like this. And then we have a focus at 0, root 5, which is like a little bit more than 2. Makes sense that it's closer. Like, I don't know if you guys are noticing this, but when you're closer, you're smushed together more. And if you're further apart, you're wider. Oh my god, so fun. Anyways, focus, focus. Okay, so now I'm just going to show you a couple pages and have you try a few. So, first of all, let's try 2 hyperbolas. So we'll do x squared over 9 minus y squared over it's just, my graphs are too small, minus 1. And we'll do y squared over 16 minus x squared over 9 equals 1. So give those 2 a try. We're also going to try some ellipses. So I'm back on ellipse page now, and we'll try the ellipses. Let's see. We'll do x minus 2 squared over 16 plus y squared over 4 equals 1. And then we'll do x plus 3 squared over 4, 2 squared over 9 equals 1. Okay, so try those 2 ellipses. I'm actually going to give you a couple of circles to try too. So with circles, we're going to try x squared plus parenthesis y minus 1 squared equals 1, and then x squared plus y squared equals 5. And then we'll try some parabolas as well. So all the way back on parabola page, got 2 parabolas for you to try. And I will post all the answers to the examples later, so good luck.